Last time, we talked about defining our overall design problem in an overarching way. And in this video, we're going to talk about coming up with various particular requirements for the product or process that we're designing. Just like with problem definition, coming up with these various design requirements involves evaluating the interests of a wide range of stakeholders. And we can get more into this under Design for X, which we can get into later. But for now, let's just briefly go over some of the more typical ways that we come up with our design requirements. So common sources of requirements include the designer or design team, or perhaps other people within the organization doing the product or process development, such as supervisors or folks on the business side. It can also, in the cases where there's a client or sort of a direct customer, if you will, it can include that person or entity. And then, of course, it can include discussions, interviews with end users or anticipated end users, people who will be making the purchasing decisions, to the extent that may not always be the end user, and other stakeholders that can either be involved with or affected by the product or process being developed. You're also going to want to give some consideration to any existing norms or expectations there might be regarding the type of product or process you're designing. That doesn't necessarily mean you're always going to follow it, but it could depend on the level of novelty or originality in your product. But it needs to be considered, and you need to decide, make sure it's a conscious decision to what extent you are or are not going to follow sort of established conventions in that particular product area. And also you need to take into account the context in which your product or process is going to function. Another point I want to make is similar to one that we discussed regarding overall problem definition, and that's that for each particular requirement that you're trying to capture and understand in this at this stage, you want to make sure that you're striking a careful balance of preserving enough flexibility while still getting the necessary guidance. So for example, if you're designing a machine and you learn that it's going to need some cooling capability, somebody may instinctively be used to using a fan for that type of cooling, and so they'll say, oh, it has to have a cooling fan near this region. Well, you might question whether it necessarily needs to be a fan or just cooling capability more broadly. Now, this could be taken even further, and you might question whether you have the discretion to design it in such a way that excess heat isn't generated and you avoid the need for cooling capability. So at some point, there's diminishing returns to exploring such alternative possibilities, but it's worth making the inquiry and thinking through where the right balance is in getting the input while preserving flexibility. Again, those are judgments that come with experience, particularly in a given field or in a given product line. Just be mindful of the fact that that's a balance we'll always be looking to strike. Another general point I want to make before I get further on this topic is that the amount of time and effort and detail we put into the requirements phase will depend somewhat on how structured we need to be in organizing our plan for a particular design project. And that will in turn depend on factors such as how complex the product or process is that we're designing, and how hard or easy it would be to change at various subsequent points in the process. It's always important, no matter what, to spend at least some significant time up front defining your requirements. But the extent of it will depend on those other factors. And we'll get a little more into that when we talk about project planning in a subsequent video. But for now, just keep that general point in mind. So, what exactly is involved in coming up with our list of particular requirements? Well, first off, requirements is generally the broad umbrella term that includes various types or categories of requirements. So with the usual caveat about how much the terminology and classifications can vary, here is a typical breakdown that we'll use to introduce these typical categories. We can think of two different dichotomies in how we classify requirements: functions versus attributes, and objectives versus constraints. Functions versus attributes is about what something does versus what something is or has. So, for example, a function might be propel or contain, whereas an attribute might be about something's size or noise. As a separate dichotomy, or on a separate axis, if you will, we have the issue of whether something is a binary yes or no type of requirement, in which case it could be termed a constraint, or whether it's something we have discretion to weigh how well we satisfy it in light of other competing requirements, in which case we call it an objective. As an aside, I just want to mention here that the word constraint often has a negative connotation, but the way I'm using it here, it's neutral. It simply means it's a yes or no binary proposition, even if it's a positive requirement. So for our purposes here, saying, it must have at least X capability in a particular area, that would be a constraint, even though it's phrased as a positive thing. Another area of overlap with these is that something can be a subject of both an objective and a related constraint. This comes up a lot with tolerances. For example, when refining your requirements during detailed design, which we'll talk about later, that tends to be a phase where a lot of these requirements get refined further, physical dimensions will often be specified with tolerances. And if you specify a particular dimension and you specify a tolerance for that dimension, the target dimension is an objective because we want to get as close to it as possible, whereas the tolerance indicates our constraints. So, for example, if we have a particular dimension that we specify a target value of 2 millimeters and we specify a tolerance of plus or minus 0.1 millimeter, the objective is 2 millimeters and the constraint is that it be between 1.9 and 2.1 millimeters. And that's just one example. Basically, anytime you have both a hard limit and a desirable aim relating to the same requirement, you could have an objective overlapping with a constraint. Now, I want to go back and talk about functions some more. A few points about functions. First, there can be some gray area between function and attribute. And whether you classify something as a function or attribute can sometimes seem to come down to how you phrase it. So for example, being fast versus going at a certain speed, or being capable of something versus doing that thing. Don't worry so much about that. If it's in a gray area and could be classified either way, just pick one, use your best judgment. The most important thing is that you capture the requirement. And with experience, you'll cultivate a better sense of which classifications are more meaningful or more helpful for a given project. But by and large, the most important thing is that the requirement get captured. So don't worry so much about that. Secondly, about functions, sometimes there will be a sort of presumption, sometimes explicit, sometimes implicit, that functional requirements are the more important ones, that there's something inherently more real or more higher priority about functional requirements as opposed to attribute requirements. This isn't necessarily wrong. There's that bias has some good reasons behind it, but we have to keep it in check because there certainly are situations where attribute requirements are actually the focal point of a given project. So for example, if you're designing a portable version of something and non-portable versions of that product already exist, and the essence of our project is that we're making a portable version, then that attribute of portability is pretty critical. Yes, the functional requirements are also still very critical, but what's different about our process in that case is that we're making it portable. So the same thing could go for user friendliness and a host of other attributes. So again, just keep that bias somewhat in check. The third point I want to make about functional requirements is that functions can often be decomposed or broken down into various subfunctions and sub-subfunctions, etc., for any given product or process being designed. In fact, functional analysis, also called functional modeling sometimes, is a fairly common and important aspect of many engineering design projects. And the requirements stage is often one, but not the only stage where that can be very useful. There are various approaches to functional analysis that have been developed. Some are fairly common, such as functional block diagrams. And a key theme of these various approaches to functional modeling is this idea of trying to separate the functions that we want to see happen from any particular means or structure that's going to accomplish those means. Now, yes, there can be some gray area in that, but that's the idea, is to try to, at least on some level of abstraction, think about the functions that need to happen separately from how they're going to happen. Okay, at this point, I want to talk about the issue of how objectively clear or not a given requirement is. So, whether something is a function or an attribute, and whether it's an objective or a constraint, we have this sort of separate issue of, is there room for interpretation? Room for ambiguity as to whether we've met it in the case of a constraint, or how well we've met it in the case of an objective. When any requirement from any of those categories we discussed can be assessed in a reasonably objective manner, such that there's essentially no ambiguity about whether or how well we've met it, then it's often termed a requirement specification. So, just to be clear about this, whether it's considered a requirement specification is really separate from any of those other categories that we've discussed. So, as a simple example, if we say that something has to weigh less than 10 kilograms, it's an attribute because it's about its weight. It's a constraint because it's yes or no whether it's less than 10 kilograms. And it's a specification because it's objectively determinable whether or not we've met that requirement. I also just want to make a brief aside here about the fact that I'm using the term objective in two senses. So one is in contrast to what we're calling a constraint, and the other is in contrast to subjective. So Hopefully it was clear, but just to point that out explicitly. Also, in that case of the example I just gave, it's a quantitative specification. And usually specifications will be quantitative, but not necessarily always. There are situations where something is objectively determinable, but qualitative. So for example, a particular material type or a particular power source. These can still be considered requirement specifications, even though there's not necessarily a number attached to it. But a requirement that's truly indefinite, like portable, for example, is not a specification. Is that necessarily a problem? Well, we'd like for as many of our requirements to be in the form of specifications as possible, but we don't want to use a false precision. So we don't want to be we don't want to be any more specific than what we can justify. So if our background research, our interviews with stakeholders, our own engineering judgment, other sources of information that we have at the time lead us to a justifiable position about what a specification should be. So in the example of portability, what particular weight, what particular dimensions will support that, that concept of portability, then sure, by all means, let's be more specific. Let's make it a specification. Let's give ourselves some concrete requirements that are ascertainable through testing and inspection later on when we get to the evaluation stage. But if not, if we don't really have a solid basis to support that additional detail, it's really important that we not just make it up or speculate without adequate basis. So we need to decide. Either we gotta pause, do more research, or we make the judgment that we can proceed at least somewhat with a somewhat indefinite requirement for now, and then at some point later we are gonna have to refine that, or in some instances, if we go all the way to validation without having made our requirement more objective, then we're taking a significant risk. There are times when that's not avoidable. We can talk more about that later. But the bottom line is an honest subjectivity is better than a false objectivity. All right, now I just want to close with a couple general points about requirements. The first deals with priorities. So despite our use of terms like requirements and user needs, the fact is not all of what we're going to list as requirements are equally important. Some of them are really wants. And part of the upfront research that we need to do, and conversations with various stakeholders and contemplation within the design team, is to get a sense of the relative importance of various requirements. So with objectives, remember that's where we specifically have some amount of discretion to weigh various requirements in light of other requirements. So there it's particularly intuitive that we're going to need a sense of the relative importance. But even with constraints, sometimes we use the term soft constraint to refer to something that's a yes or no binary proposition, but it's not necessarily essential. So for example, we might have a situation where if possible, we'd like something to be battery powered in addition to being plug-in, but you know, if that's not essential, if at least for an initial version or the first generation of a particular device, we might be okay if it can't be battery powered. So that's just one example where you might have what's sometimes called a soft constraint, because it's yes or no, you either meet it or you don't, but we don't necessarily need to meet it. We can weigh that in light of other things. The other general point I want to make about requirements is that there is a difference between design requirements and project requirements. So what do I mean by that? Well, the project considers things like your deadlines and your budget that don't necessarily relate to the actual product or process you're designing. Yes, there's some indirect impact on those things perhaps, but the design requirements are those that relate specifically to the product or process you're designing. And when we get to project management in a subsequent video, we'll talk more about that distinction and some of those broader considerations. So I just want to make sure that, that we're clear about that at this point. So keep that in mind for later. So once you have at least an initial iteration of your list of requirements for what you think is going to be needed for the product or process you're developing to solve the problem that you had identified, the next step is to get to what's often considered the first of the fun parts, which is ideating or generating concepts for candidate solutions. So that's where we'll pick up next time.